Hey everyone, in this video I'll be talking about the squeeze theorem. The squeeze theorem states that if we have some g of x that is less than equal to some f of x, which is less than equal to some h of x, and we also have that the limit of g of x is equal to that of the limit of h of x, and let's say this limit is equal to some c or maybe L to avoid confusion, then we have the same limit for the f of x. We can think about why this makes sense conceptually by drawing a graph of the three functions, which a larger and smaller function that both approach the same limit at the point of interest. What we end up seeing is that those two outer functions squeeze the inner function, and hence why we have the squeeze theorem. To really get an understanding of how to use the squeeze theorem, let's go over some examples. First, some sinusoidal examples which are very commonly asked about. We have to evaluate the limit as x approaches infinity of 2 minus cos x all over x plus 3. In order to get started, we have to use the fact that cos x is valued somewhere between minus 1 and 1 always. And furthermore, minus cos x is also captured by the same bounds. Now our goal is to get the term that's in the middle to look like the function in our question, the 2 minus cos x all over x plus 3. We start by adding 2 to the middle, thus 2 to each side, so we get 3 on the left, 2 minus cos x in the middle, and 1 on the right. Then we just divide everything by x plus 3. Now you see the middle function is how we want our f of x, but we also have our g of x on the left side and our h of x on the right side that are required for squeeze theorem. All we have to do is see if the limit of 3 over x plus 3 and 1 over x plus 3 as x approaches infinity are the same. And as it turns out, they are. They both equal 0. Therefore, by squeeze theorem, we can conclude that the middle function's limit is also 0. Now let's look at our second example, which is similar, but we need to do an extra step. Since we are looking at x approaching 0 and we are looking at sine 1 over x, we get some undefined behavior. We can substitute t for 1 over x. Doing this changes our function to become 1 over t squared times sine t. We can then use the same logic as our previous question to bound sine t between minus 1 and 1. Then multiply each side by 1 over t squared. Then all we have to do is take the limit of each side as t approaches infinity. And we see that two functions that sandwich our function both go to 0, and therefore we can conclude that the limit of the function in question will also be 0. Squeeze theorem isn't just for solving the sinusoidal limits, you can also use it to solve limit for something like this as well. The limit at infinity of 3 to the x minus 5 to the x all over 3 to the 2x plus 2 to the 4x. We need to look for a g of x that is smaller than this function and an h of x that is bigger than this function. In order to get a function that is smaller, we can do two things to the original function. We can minimize the numerator or maximize the denominator. We can rewrite the original function like this, so that the denominator has 9 to the x plus 16 to the x. Now we can start by minimizing the numerator by subtracting 3 to the x. Then we can maximize the denominator by changing the 9 to the x into another 16 to the x term. This lets us group them together like so. Then we can do some factoring, so we are left with a 5 over 16 to the x exponential decay function, which will be our g. Next we need our h, which is going to be our bigger function. Hence we do the opposite of what we did for g. We maximize the numerator and minimize the denominator. We can maximize the numerator by adding 5 to the x to the top, so we are left with 3 to the x. Then we can remove either term in the denominator to maximize it. So let's remove 16 to the x, though it doesn't matter which one you choose. We can simplify, though it isn't necessary. The only thing that's important to see is that both of these functions are exponential decays that approach 0 as x approaches infinity. And because of the squeeze theorem, we can conclude that the limit of the original function is also 0. So that is all for squeeze theorem. I hope this was helpful. Thanks for watching.